Algebra 2, 3.4b, we're going to graph linear equations. Now, we're in Lesson B, so if you haven't seen 3.4a, you can go to this video's description and just click on the link. And if you haven't seen the previous videos for Chapter 3, you may get confused, okay? You're kind of walking into the middle of the chapter here. So, theorem we have here says the graph of any linear equation is a straight line. Well, since 2 points can be connected to draw a line, we can graph a linear equation by finding 2 points that belong to the graph. Then we draw a line containing those 2 points. And it's very wise to use a third point somewhere in the middle to make sure the line is accurate. Usually, the easiest points to find are those that cross the axis for x and y. So now we have a definition. Here's our definition of x and y intercepts. The y-intercept of a graph is the y-coordinate of the point where the graph intersects the y-axis. It crosses it. And the x-intercept of a graph is the x-coordinate of the point where the graph intersects the x-axis. So that's where it crosses the x, okay? So the y-intercept crosses the y-line, and the x-intercept crosses the x-line. That's all it's saying, okay? So to find the y-intercept, we just let x equal 0, and then we solve it for y. And we can flip that around. To find the x-intercept, we let y equal the 0, and then solve for x. So if we needed to graph 4x plus 5y equals 20, we need to first find the intercepts. So we're going to find y as x equaling 0 and plot the point. Then we're going to find x with y equaling 0 and plot the point, and then we're going to draw the graph. So we're going to plug in 0 for x right here to find y. So in the equation, if we put a 0 where the x was, we get 4 times 0 plus 5y equals 20. Well, that's just going to be 5y equals 20. We can divide both sides by the coefficient 5 here and get y equals 4. So now we know that the y is at 4, okay? So that is where the line is going to cross through the y-axis right here at the 4, see? And we had set the x to 0, didn't we? So now our ordered pair is 0, 4. Well, now we're going to find the x by setting the y to 0. So now we say, okay, now the y is 0, okay? So we put a 0 here. And we've got 4x plus 5 times 0. Well, that's 4x times 0. We can divide each side of the equation by this coefficient 4, and we get x equals 5. 20 divided by 4 is 5. So now we know that x is 5 when y is 0. So now we have two ordered pairs, 0, 4 and 5, 0. And we know that it's crossing the x-axis at the 5, see? So now we have our 2 points. We can draw our line. That is the graph of the equation 4x plus 5y equals 20. And every point on this line will satisfy this equation. So if we find a point like right here where it crosses, this is at 5 and 8. We could use 5, 8 as one coordinate for like that one. And then we could find another coordinate like 4 and 1 for that one, and then we could draw the line. And those would be solutions to that equation. Every single point on this line would be ordered pairs that would satisfy that equation, okay? Even little tiny decimal ones and fraction ones, okay? So the graph of any equation in the form y equals mx contains the origin 0, 0. So it's going to go through 0, 0 as a point. Y equals mx. Automatically, we know it's going to go through 0, 0. The x-intercept and the y-intercept both occur at the same point at 0, 0, the origin. Now, another point will be needed to graph the equation. We only have one point at the origin, 0, 0, right there. And it's wise to choose a point that isn't close to the first point so the line will be more accurate. And I'll show you. I made a function table to find out what x and y could equal. And I said, okay, well, if x is 0, then y is going to be 0. Because if x is 0, 2 times 0 is 0, so y equals 0. And if x is a 1, then that's 2 times 1, that's 2, then y equals 2. And if x is a 2, then that's 2 times 2 is 4, so y is a 4. I made my function table to find all the values in the ordered pairs. So because we're going through 0, 0, I knew that one point was at 0, 0, and so that it would be more accurate, instead of choosing 1 and 2, like here, because it's so close together, I chose 4 and 8 because it was nice and far away. And I could have chosen 2 and 4 right here as a third point to kind of make sure that my graph was a straight line, so it would be more accurate. Now, the reason I drew both of these is I wanted to show you the difference. Now, these are very big squares, so it wasn't very hard to draw 1 for x and 2 for y and to make the line, because the squares are so big, they were kind of a little bit farther apart. But what happens when you're using graph paper where the lines are really close together? It's very hard to make an accurate line. So it's smart to choose one farther away so that you can make a very accurate line, okay? These 2 points are too close together. So when you're using tiny square units on graph paper, you're going to definitely want to choose a point farther away. And you'll find that if you do it this way, when you look at your line up here, it might not be at 4, 8. It might be at 4.5 and 8 because it got off course, okay? So try to use ones that are a little farther away from each other so you can have more accuracy, all right? Okay, now let's check this out. Now remember I showed you this in the last video, this card. It said linear equation, slope-intercept form. Well, that's exactly what we're getting into. The graph of y equals mx is the straight line containing that origin 0, 0. If we add a number b to the right side of the equation, b is going to become the y-intercept instead of the 0. So if it says to graph y equals 2x minus 3, this minus 3 is the b. Because of the minus 3, our graph is going to move down 3 units. So to graph this equation, we need to find x and y values that make this true. So I try a negative 1 for x. Well, that would be negative 2 minus 3. That would give me a negative 5. If I use 0, well, 0, x is a 0. 0 times 2 is 0. 0 minus 3 is a negative 3. If x were a 1, it would be 2 minus 3. That would be a negative 1. If it were a 2, it would be 2 times 2 is 4 minus 3. Then it would be a positive 1. And if that was a 3, 2 times 3 is 6, minus that 3 would be a positive 3. So now I've got my function table of values, and here's the original line going through the origin, okay? And I chose to use 3 and 6 as my point, which was one of the ordered pairs I could have chosen, all right? So that's what I did on this one instead of the 4 and the 8. I could have chosen the 4 and the 8. It's right here. It's still on the graph. See? When you look at the graph of this one, look at that. It's parallel to the one above that we did. These two lines are parallel. This one went through the origin and through 3, 6, and 4, 8 here. And this one went through 0 and negative 3 right here. See, that's not a 4. 4 is below it. It's negative 3 is the y-intercept. See that? And then up here, I used 3, 3. See that? I used that ordered pair. And it ended up making parallel lines. All this purple line did was shift down 3. See? It went down minus 3 spaces. It went down minus 3 units. 1, 2, 3. If this was a plus 3, then our purple line would have moved up 3 units from the pink one. If it was a plus 3, we would have been up here, and the purple line would have been above the pink line. See? So I have a theorem for you. You ready? The graph of y equals mx is a line containing the origin, and the graph of y equals mx plus b is a line parallel to y equals mx, and the b is the y-intercept. So that minus 3 ended up being where it was intercept. See? So if you see an equation like this and you need to graph it, you know right away that this is the y-intercept b. All right? This is called the y-intercept b, and you know that the y is going to be intercepted at the -3. So it tells you that just from the equation. So you have 1 point already. Then all you have to do is solve for the x to find out where the other point can be. Okay? Isn't that kind of cool? All right. So our next video is 3.4c, and we're going to talk about lines that are parallel to the axes. Lines that are parallel to the x-axis and the y-axis. So the lines are actually going to be straight horizontal lines or straight vertical lines, okay? And I'm going to add this video to the Algebra 2 playlist that you can go to this video's description and click on those to review for tests and stuff. And there'll be links to the Graphs and Linear Equations playlist for Algebra 1 and Relations and Functions playlist for Algebra 1 also. All right? So you couldn't possibly get a bad grade on a test because I'm giving you so many tools to do well. All right? You could even just start watching in the Algebra 2 playlist with the beginning of Chapter 3 at 3.1. Watch all those videos and kick back and spend a good half hour, 45 minutes watching all those videos, and you'll be done studying. Wouldn't that be easy? All right? I'll see you next video, and we're going to continue on to our lesson for Lesson 4. Bye.